Hi students, welcome to today's class. In this class, I am going to explain the proof of the equation of the tangent to the ellipse at a point. Now the statement is the equation of the tangent to x square by a square plus y square by b square is equal to 1 at a point x1 comma y1 on it is, the point is on the parabola, sorry, on the ellipse is x1 upon a square plus y1 by b square minus 1 is equal to 0. In short, we can write it as a s1 is equal to 0. Generally, in our classes, the students used to learn that just they by heart this formula. But try to learn those who are preparing conceptually mathematics. So, try to learn the proof of this statement also. Okay, now very easy to learn. Almost for all ellipse, parabola, hyperbola, the same concept will apply. Okay, now let us start the proof. So, in calculus, you can find out very easily, comparatively, geometrically, calculus part very easy. Already point x1 comma y1 is given. So, find the derivative of this equation dy by dx, and you substitute this x1 y1, you will get the slope. After knowing the slope, point slope form y minus y1 is equal to m into x minus x1, you will get the equation of the tangent. But here I am doing this theorem using geometrically. How to solve the do this find the equation of the tangent geometrically. Okay, na? So let us see that. First, there is an ellipse here whose equation is x square by a square plus y square by b square is equal to 1. Okay, now right here let us take, there are 2 points on this ellipse, that is x1 comma y1 and q x2 comma y2. There are 2 points I am taking, 2 points on the ellipse p x1 y1, another point is x2 y2. So since p x1 y1 lies on the ellipse, we have x1 square by a square plus y1 square by b square is equal to 1, call it as equation number 1. Since the point x2 comma y2 lies on the ellipse, we have x2 square by a square plus y2 square by b square is equal to 1, call it as second one. Okay, now right. Now what I am going to do is 2 minus 1 I am doing. On the whole, I am going to find out the equation of the secant. PQ is called equation of the secant. Okay, na? So I am going to find out the slope of this secant, that is y2 minus y1 upon x2 minus x1. Let us see here. Second equation minus first equation, that is equal to x2 square minus x1 square by a square plus y2 square minus y1 square by b square is equal to 0. Understand this? Next one. So from this y2 square minus y1 square by b square is equal to, take to that side, minus x2 square minus x1 square by a square. Okay, right. So this implies y2 square minus y1 square by, we have to put a bracket here, right, x2 square minus x1 square is equal to minus b square by a square. Okay, now right. From this a square minus b square, here also a square minus b square is there. So you can do like this, y2 plus y1 into y2 minus y1 by, here x2 plus x1 into x2 minus x1 is equal to minus b square by a square. Okay, now we want y2 minus y1 by x2 minus x1. So this implies y2 minus y1 upon x2 minus x1 is equal to minus b square times x2 plus x1 by a square times y2 plus y1. Okay now. So y2 minus y1 upon x2 minus x1 is given by minus b square times x2 plus x1 upon a square times y2 plus y1. Now what is this y2 minus y1 upon x2 minus x1? This y2 minus y1 by x2 minus x1 is nothing but slope of the secant PQ. Understand? Now I am going to find out the equation of the secant PQ. Okay now? So we know the 2-point form y minus y1 is equal to y2 minus y1 by x2 minus x1 times x minus x1. That formula I am going to apply here. Okay? Let us continue the class. Welcome back. So here we know the slope of the secant PQ. Now we are going to find out equation of PQ. What is equation of PQ? Secant PQ. Y minus y1 is equal to y2 minus y1 upon x2 minus x1 times x minus x1. Y minus y1 is equal to y2 minus y1 times upon x2 minus x1 by x minus x1. So this implies y minus y1 is equal to, what is y2 minus y1 by x2 minus x1? Already we got here. Okay. So what is that? Minus b square x2 plus x1 by a square into y2 plus y1 into x minus x1. Very nice. Now coming to the concept. Already we know that tangent is nothing but a limiting position of secant of a curve. The limiting position of secant of a curve is nothing but tangent. What is the meaning of that? See here, as x2 and y2 value approaches to x1 and y1 values, that means if these values are approaching, then you will get these secants will become tangent. The secant will become tangent. That means as x2 value approaches to x1 and y2 value approaches to y1, the secant of the tangent, secant of the curve will become tangent at the point to P. That means at a limiting case. So at a limiting case, we have x2 tends to x1, y2 approaches to y1. As x2 value approaches to x1, y2 value approaches to y1. That means it is not exactly equal, but is approaches to the secant of the curve will become tangent at the point P. Okay now then. So that means in the limiting case, so wherever x1 is there, so you substitute x2, wherever y2 is there, substitute y1. Okay now. So this implies y minus y1 is equal to minus b square. In place of x2, substitute x1. So x1 plus x1, 2x1 by a square into, in place of y2, substitute y1. So this is equal to 2y1 times x minus x1. Right, 2 will get cancelled, and so cross, let us do a cross multiplication. So you will get like this. If you do a cross multiplication, y1 minus y1 into y1 square is equal to minus b square by a square into. So you multiply this here, x1 minus x1 into x1 square. x1 into x1 square. Now let us do one more calculation. So take this minus b square to this side, otherwise take only b square. So this is equal to y1 by b square. So this is equal to minus y1 square by b square is equal to, so this is equal to minus x1 by a square, minus into minus plus x1 square by a square. Okay now. take this minus to left hand side, this minus y1 square to right hand side. So you will get x1 upon a square plus y upon b square is equal to, there you got x1 square by a square plus y1 square by b square. So this x1 square by a square plus y1 square by b square value is 1 according to the equation number 1. So you bring this side, you will get almost this equation x1 by a square plus y1 by b square. This value is equal to 1. So bring this side, minus 1 is equal to 0. This is the equation of the tangent at the point P x1 comma y1. The same logic will apply for any one of the curve. Let us you take a parabola, you take a ellipse, you take a hyperbola, even you take a circle also, the same concept is applies. Okay now, right. So the case here we have to understand is, it is a limiting case. As a limiting case means as x2 approaches to x1 and y2 approaches to y1, this q will approach to P as a limiting case. The secant will become a tangent at the point P x1 comma y1. Okay na? Right. I hope that you understand this proof of the equation of the tangent. So in short, we will write it as this expression, this algebraic expression, this first degree algebraic expression. We in short, to remember easily, we represent it as a s1 is equal to 0. Okay now. So in a general case, I told for a equation of any tangent at a point x1 comma y1 on any curve, simply in place of x square substitute x1, in place of y square substitute y1, in place of 2x substitute x plus x1, in place of 2y substitute y plus y1. If you substitute, you will get equation of the tangent. Okay, I hope that you understand this concept. So let us go for next concept. Welcome back to this concept. The concept is here, the equation of the straight line joining two points on the ellipse whose eccentric angles are given by alpha and beta is given by the equation x by a cos of alpha plus beta upon 2 plus y by y upon y by b sin of alpha plus beta by 2 is equal to cos of alpha minus beta by 2. Okay now, right. So this is a first degree equation, it is the equation of the straight line, right. So it is given that, so there is an ellipse, of course it is not given, x square by a square plus y square by b square is equal to 1. Of course it is not given, actually it should be given. X square by a square plus y square by b square is equal to 1, where a greater than b. So if it is unless otherwise stated, we have to take the ellipse equation as like that. There are 2 points on the ellipse. There are 2 points. So here P, another one is Q. So if you join this P, Q, if you join that P and Q, so whose eccentric angles are alpha and beta? Already I explained what is eccentric angles. So eccentric angle means you have to take the help of auxiliary circle. Okay, already we explained yesterday's class what is a eccentric angle. Okay, so what is the eccentric angle of P is alpha, the eccentric angle of Q is beta, then the equation of the line joining those 2 points P and Q is this, that we have to prove, very easy one. When he is saying the eccentric angle of the P is alpha, we can take the P point as A cos alpha comma B sin alpha. A cos alpha comma B sin alpha. When he is saying the eccentric angle of the point Q is equal to A cos beta comma B sin beta. Okay now? Right. Now here the 2 points are x1 y1 and x2 y2. So let us call it as this as a x1 y1 x2 y2. Okay now, we know that equation of the line passing through the 2 points x1 y1 and x2 y2 is y minus y1 is equal to y2 minus y1 upon x2 minus x1 times x minus x1. So this is the equation of the straight lines passing through 2 points. Now substitute these values. So y minus y1 value is b sin alpha is equal to y2 minus y1. So that is equal to b sin beta minus b sin alpha by x2 minus x1, that is equal to a cos beta minus a cos alpha. X minus x1, a cos alpha, x minus x1. Understand this? So from this, almost geometry part is over. The only thing is trigonometry part. So the trigonometry is here y minus b sin alpha is equal to, first you take b common outside. This is sin beta minus sin alpha upon, take a common outside, cos beta minus cos alpha times x minus a cos alpha. Right, now in transformations trigonometry we know that sin c minus sin d formula, cos c minus cos d formula, you apply here, so you will get here, so y minus b sin alpha is equal to, y minus b sin alpha is equal to b into sin c minus sin d. So sin c minus sin d means how much? 2 cos of c plus d by 2 into sin of c minus d by 2 divided by cos c minus cos d formula, that is equal to a is equal to minus 2 sin c plus d by 2 into sin c minus d by 2 times x minus a cos alpha. Then you can cancel sin b minus alpha by 2, sin b minus alpha by 2, you can cancel, and you bring into the left hand side and all the rearrange the terms, simply rearrange these terms, you will get here, see here, cos of alpha plus beta by 2 is there, sin of beta plus alpha by 2 is there. There again you will get simplify that, sin alpha and cos alpha also you will get, and you will get cos of alpha minus beta by 2 is also you will get. Okay, I hope that you can do this type of smaller calculation part. The only idea is here, whenever it is given that alpha and beta are eccentric angles, it is given eccentric angles, then it is easy to find the equation of the line passing through the point P and Q by taking P point as a cos alpha, b sin alpha. Second point, this is a cos beta comma b sin beta. Okay, now, right? I hope that you understand this concept. So let us move to next concept. So welcome to the next concept here. Our concept is position of a line with respect to an ellipse. So if you are given an ellipse and a line, so if you are asked to draw a line and ellipse in a plane, then what are the different possible cases you will get? Let us see that. So this is an ellipse and it is a straight line. So here the ellipse and straight lines do not touch each other. The second case is the ellipse and it is a straight line. That means the ellipse and straight line both are touching at a point P. So this is called point of contact, and this line is named as tangent of the ellipse at the point P, right? What is the third case we will get? So third case is, let the line may intersect at a 2 point. Let the line may intersect at the ellipse at 2 points A and B. So in this situation we call it as a secant. Only these three cases we will get. Is there any more case we will get here? Nothing. Why? Because so the first case is ellipse and line, they do not touch each other. Ellipse and straight line, they touch at a point P, and ellipse and straight line both intersect at 2 points at A and B. Okay, now, so these are the three cases that we have. Now, given a straight line, so I have given one straight line, y is equal to mxc form, and a parabola x square by a square plus y square by b square is equal to what? There are it is a ellipse. Y is equal to mx plus is a straight line, x square by a square plus y square by b square is equal to what? It is an ellipse. By seeing these values m, c, a, b, m, c, a, b, by seeing there any relation, by seeing a the values of MCAB. Can we get any relation between MCAB so that we can decide the line do not touch each other, the line is a tangent, the line is a secant, that we are going to see. That means if I given one line equation, for example, y is equal to some 2x plus 3, some x square by 4 plus y square by 3 is equal to 1. So, y is equal to 2x plus 3 is a straight line. So, x square by 4 plus y square by 3 is equal to 1 is an ellipse. Then how to decide this line, position of this line, relative position of the line and the ellipse. Okay, now consider a straight line y is equal to mx plus c and equation of the ellipse as x square by a square plus y square by b square is equal to 1. Then we are going to get a relation between MCAB, so that depending upon that we will decide all the three cases. Now let us solve these two equations. So the straight line equation and ellipse equation. How to solve it? Very easy thing is, in place of y substitute mx plus c. Okay, so this implies x square by a square plus in place of mx plus c whole square by b square is equal to 1. Okay, so upon simplification we will get that b square x square plus a square into a plus b whole square, you expand it. So, m square x square plus 2mcx plus c square is equal to a square b square. Here LCM is a square b square, it will get cross multiplication. Here b square, here a square, a plus b whole square. Now here x square we got. So here we are going to get a quadratic equation in the variable x. Okay, so this is nothing but b square. So here see here a square m square into x square. So this is the x square term. Next you will get 2a square mc into x. 2a square mc into x, that is a x term. Coming to the constants, here a square c square. So this a square b square also bring to into left side. A square b square is equal to 0. Now this is a ax square plus bx plus c is equal to 0. That means, so this is a coefficient of x square, this is coefficient of x, this is constant. So you got a quadratic equation depending upon the roots of x. So you can decide whether if it is a do not touch either it is a touches and it is intersects let we will decide. That means if it has no real roots, then we say that the first case arises. If it has equal roots, that means we can decide the line touches the ellipse. If it has two distinct roots, different roots, real roots, then we say that the line intersects the ellipse. This all will decide by a quantity known as discriminant. So here the discriminant is equal to delta is equal to b square minus 4ac. Depending upon this b square minus 4ac value, if it is greater than 0, the third case arises. If it is equal to 0, second case. If it is less than 0, first case. What is b square? B square means this quantity. 2 times I am finding delta value, that is a b square means x coefficient, 2a square mc whole square minus 4 into a means x square coefficient, that is a b square plus a square m square into c. C means a square you can take common outside, you can take a square common outside, c square minus b square. So this is the discriminant, b square minus 4ac. Let us simplify this. So this we can write it as 4 times a power 4 m square c square minus 4 times. So this is equal to 4a square into b square into a square m square into c square minus b square. First we will find out the tangent condition. Tangent means what? It should have the equal roots. Equal roots means what? Is equal to 0. Delta is equal to 0. Now let us simplify this. Here 4 will get cancelled. A square also will get cancelled. So first you cancel that, you will get, so here 4 will get cancelled, A square will get cancelled. So here you will get A square m square c square, A square m square c square minus here 4A square we get cancelled, and you multiply this here, B square c square minus b to the power of 4, b to the power of 4, and you multiply these two also, A square m square c square, A square m square c square minus you multiply A square m square b square is equal to 0. Okay, now open the brackets, you open the brackets, let us see what happens. A square m square c square minus b square c square plus b to the power of 4. So this is a plus, no, minus A square m square c square plus A square m square b square is equal to 0. Okay, now, so any more cancellations? Yes, we can cancel this A square m square c square minus A square m square c square. So next here b square is there, b power 4 is there, b square is there. That also can be cancelled. Why? Because it is not equal to 0. So this is a minus c square plus b square plus A square m square is equal to 0. From this we will get c square is equal to A square m square plus b square. So this is the condition. So what is the tangent condition? C square is equal to A square m square plus b square. That means if C square is equal to A square m square plus b square, then the line touches the ellipse. The line y is equal to mx plus c touches the ellipse. Okay. If it is do not touch each other, that means do not touch each other means what? What you will get here? This discriminant should be less than 0. Less than 0 means what? This is less than, and here also you will get less than. If it is a less than, c square less than A square m square plus b square, then the line do not touch the ellipse. If c square is greater than, so if it is a c square is greater than A square m square plus b square, the line intersects the ellipse at 2 distinct points. Okay, now I hope that through what are today I discussed all these 3 topics. You enjoyed this today's class, and tomorrow's class with some more topics I will stand before you. Until then, all the best.